Hello everyone, today we're going to look at usaco-training, controlling companies. Okay, so in this problem we're given some companies and then we're supposed to given some data. We're supposed to compute which company owns another company. Okay, so here are the constraints for company A to own company B. So if company A is equal to company B, then company A would own company B. And if company A owns more than 50% of company B, then company A would also own company B. And if company A also controls K companies such that each of those companies, the sum of those companies are greater than 50%, then company A also owns company B. Okay, so we're given I, J, and P, or a set of n numbers, so it would be I, J, and P. So it would be that company I owns company B, company company I owns company J, P%. Okay, so then we just print the ordered pairs out. So for this example, we're given company 1 owns company 2, 80%. Company 2 owns 80% of company 3, and company 3 owns 20% of company 1. So then, company 1 would own company 2 because it directly owns over 50%, and company 2 directly owns company 3 because, again, it's over 50%. And company 1 owns company 3 because, as you can see here, company 1 owns company 2, and company 2 owns company 3. So then, by the third constraint, the third constraint, you know that company 1 also owns company 3. Okay. And notice that there are like at most 100 companies. Okay, so we know that we have to calculate the number of companies that A owns B. Okay, so since A is in the range, or the companies in the range from 100, we can actually make a brute force algorithm from this. Okay, so first thing first, we need to loop through each of those companies. So we basically loop through A from 1 to 100. Okay, so now we're going to try to make like a depth first search to search the number of, or which B's that company A owns. Okay, so basically we know that company A owns some amount of another company. So let's call like this company B. So we can basically loop through each company A owns. Basically, you know that A would own a P% of this company. So then, we can do you can do that basically own. Let's call this B. You would just add whatever P% it is. Then basically, if owned B, if it's just greater than 50%, then you can basically like recursively solve for that. So basically, you can mark B as owned, because you know that if it's over 50%, then it's owned, and then you can basically start again from B. Okay, so then after this, you just start from the number of companies that B owns, and then you just increment it. Then if it's greater than or equal to P, then you just again mark it as owned. So then overall, this would take O of n. Actually, it would just take O of n, or actually it would take O plus m, where n is the number of companies and m is the number of it's the number of like data or the number of companies that I owns. Okay, so that's basically it. And here we go. This is controlling companies. Okay, so let me include bits. Okay, so we're going to read n. So let's actually make this global. Whoops. Okay, and then basically we're going to give in these n, like n data, or I equals 0. Okay, so basically we can like basically keep track of this data by having a vector, or we can call this a vector pair. So we can use pi equals pair int. So we can basically have a pair of each company and the percent that I own. So then you would go like, let's call this owns, and the maximum n is 100. So then you would set it as that. So you're given x, y, and p, which means that cow X owns company X owns company Y, P%. So then you would read this. Okay, so then you just owns of X dot push back Y and P. Okay. So now for each company, we're going to compute which companies this company owns. So then what we can do is that we can have int n. We can have like what I said before. We have an owns, so int owns 101, or we can actually own. Okay. So then first thing we need to do is that we need to fill the own since we want to reset this. So plus 100 to 1, you want to fill this to 0. Then we're going to DFS from I. Okay. Okay, so for basically for each pair or each of your children's, for each x and owns of I, basically own of x dot first, you just increment it by the amount that is owned. So then you'd increment that by second. So basically if x dot or own x dot first is greater than 50%, then we can DFS of x dot first. But you may notice that this might actually go on infinitely if a company owns another company, but another company also owns this company. So we can have another that's called owned. So then basically we called owned of I as 1. So then if this is already owned, which means that we already calculated this, we could just continue or return in this case since this is a function. So over here, not only do we have to fill out own, we also have to fill out owned plus 101 and 0. Okay, so now over here, basically, because we don't want to print out if I equals to j, and owned and j is owned, then we can printf or just print this pair. So we would print I and j. Okay, so then hope this works. Let me run this. This is controlling companies. Okay, let me go get the input. Okay, it's compiling. Okay, so 1, 2, 1, 3, that looks correct. Let me just submit it. So here, this is com and language. Okay, and we also have to read from concom.in, the out, right, std out. Okay, so let me submit it. Okay, choosing. Okay, this is called controlling companies. Okay, 1 second, it's still okay. So there we go, and main. Okay, so looks like we are not printing anything. Created an empty file. Okay, so let's actually go back here and we can take the input. Okay, so I saw, so it's over here. It should be 100 since we aren't actually given which companies that are being used. So I guess that should work. Okay, so it looks like that is correct. So if you have any questions, feel free to leave them in the comment section below. Bye.